Hello guys, how's it going? So it's been quite a bit of time since my last demo slash tutorial slash whatever, right? Not because I've not been doing anything, just because, was lazy, right? Other stuff to do, I didn't feel like to. But anyway, I'm planning on working on a nice tutorial, at least I believe it's nice, in the near future. And I was going to need the widget I'm going to show you in a little. So I decided to make a little demo of that widget. I cleaned up a little bit the code, and I uploaded all the code on GitHub. You can find it here. So on my GitHub, I will post the link to everything, so you can grab everything. It's fine. So let's have a quick look about what I'm going to show. So it's this widget, right? So it's a widget that lets you plot stuff, let you zoom, let you pan, and everything, right? So you might remember this widget. I showed you like 2 years ago, something like that. I made it when I was still a teenager, so like a while ago, and I never released it. I was too lazy to clean it up, so I actually got to it, clean it up. I was actually scared to open the code because it was like 2 years old code, and I didn't puke that much, so it was not too bad to start with. But anyway, I cleaned it up a little. It's more usable, and I'm going to show you what I did, right? So let's jump to the code really quick. So it's just a widget. So if you know a little bit about Qt, you know what I'm talking about. It's just a widget. I created a shit tons of properties so you can set nicely and update automatically the render, like the background color, all that kind of stuff, right? Because you have a series of features, like if you press Alt middle mouse, he opens the dialog for the options, so you can change color. Terrible color combination, but who cares? Just them, right? So you can configure a lot of stuff. You can show axes, you can show numbers, and everything. So this is where all these options are set. So that widget is not doing, the option which is doing anything fancy, just a setting, calling directly to these properties. So you might wonder, okay, that's all nice, but how do I draw? So the drawing is based on points. So the widget is really stupid. It doesn't do anything for you. So it doesn't do any evaluation or anything. You provide a set of points, it draws the points for you. You can either draw points or lines. So if you provide points, you want to draw lines, it's just going to grab the first point and the second one and draw a line with those, right? So if we go and look for the paint event, that's where everything happens, right? So the function you need to implement, there is a default one, that's what the one is using, but the one you need to, if you want to override, is draw data, right? Here in the paint event, it draws the background first, the grid, and then draws your stuff, and then lastly draws the contour of the widget, right? So there is a bunch of stuff here, like draw background. The draw grid is a bit nasty because I'm computing on the fly how many how many lines, how many numbers I need to show, because I'm not rendering a massive amount of them, just the one that are actually shown. So there is all a bit of simple math there. And then there is the draw points and draw lines. So draw points is dumb stupid. I'm drawing each point. So that's the painter that Qt provides. I'm just calling draw point methods. Super simple. And instead lines is one less point, because I'm drawing lines that are set of 2. So super simple. If we look at the draw, which I forgot already how it's called, sorry, draw data. So the draw data is super simple. It provides me, again, with the QPaint painter. I set a couple of colors and craft, and then I just call whatever I want to draw, right? So that's it. I'm looping point sets, so it's a list of lists. So it's a list of points, and if I recall correctly, there should be at the beginning, sorry, for the properties, where I set the point set. So if I look for point sets, here we go. So you have 2 methods. One is add points, so it allows you to push a set of points, and clear data, it cleans up the list so it won't draw anything. So congratulations, you just made it through the painful part, which was the explaining a little bit the code, and I'm going to show you a little demo implementer of that, which is the Taylor polynomial demo I showed you a little ago. So I'm going to show you the code for that. So if we look for Taylor, here we go. So I don't know how much you know about Taylor series or anything, but Taylor series is basically you generate a polynomial in order to approximate a function. In this case, I'm approximating the Taylor, the sin function using a Taylor series. So, and the higher the degree the polynomial gets, the more accurate the approximation gets. I'm going to show you that in a little, but first I want to show you what I did. First things, I subclass the PlotWidget, right? And I just create a couple of extra variables. So one is sample count, how many times I want to sample the function, and a series of functions. So I can add those functions, and the draw time, rather than looping the points, because I don't have the points, I'm going to generate those points by doing a simple sampling, right? So I'm looping for the sample count. So in this case is 100, and I call the evaluate of the function. So the function passed in is a class which has an evaluate method, and I'm just going to evaluate, generate 100 points and storing them. Once I've done that, I'm actually called the base class draw data, because now the points are there, I just need to draw them. I implemented a key press event just to raise or lower the degree. That's not important, I will show you later. I will just show you the function. So I created an abstract class called drawable function, which you need to implement the evaluate method. I implemented the regular sin function, which basically just call it math.sin, and I will show you later. And then the sin Taylor, which implements the evaluate method, but also generate the polynomial for me. So how all these click together is here. I instantiate the plotter, the Taylor plotter. This is just for moving the widget in the middle of the line, in the middle of the screen. That's nothing important. And then what I'm going to do is I create a sin Taylor, so the regular one using math.sin. I set a color, which right now the color is not used. That's something I will have to add, or you feel free to add it and make a pull request. I also create the sin Taylor here. I actually created a sin Taylor. Where do I create the other function? Oh, I'm directly pushing here. Sorry. Okay, so the sin Taylor. I generate the Taylor polynomial, perfect, of degree 0, and I append the function. I append the other function, the regular sine one, and this one is actually not needed anymore, so I can probably remove that. Let's actually see. It will still work if I because I refactored the code, so I just left a little bit of crap around. It's still working, yeah. So those is not needed, so because I'm generating the points every time that I need to draw. So I can actually also remove the color. This should be fine. There we go. So anyway, what happens here? So when the draw column gets made, I loop the function, I sample those. Those are actually points and lines with 100 lines, and I get my result. So in this case, for the Taylor polynomial, it's degree 0. So degree 0 just means a constant. So a constant in a graph is an horizontal line. So you see, is the constant at 0. I'm evaluating the series at 0, so it's an horizontal constant. If I press plus, I'm raising up the degree. So I have like constant plus 2x, something like that, right? And you know that that's the equation of a line. So you see, I get a line with the gradient, which is aligned to the function I want to approximate, because this is the sign I want to approximate. If I raise the degree more, I get a I'm raising 2 at a time, because I don't remember, it's even an odd function, but basically it's raising 2 at a time. So I get higher degrees, so you see now I'm approximating more and more. Raise other 2, here is more accurate, even more, so I can keep doing that. And the more I do that, of course, the more it's expensive to compute, but the more accurate I get, right? So I want to keep this demo short because there is not too much to show. This just was a simple test that I did because I wanted to apply some of the knowledge I'm learning at uni, the math knowledge. So Taylor series was a nice thing. and I made this demo, and I used that as an excuse to clean up this widget. So now it's free for everyone to use. If you find any bugs, any feature you would like to add, open a request in GitHub, or even implement yourself. Just make a pull request, and that's it. All right, folks. See you later.